Hey there, hi there, ho there. Welcome back to another fun-filled unit, this time on mass wasting. Let's get into this. So, you might not be familiar with that term, but let me just kind of describe what's going on here and see if you can kind of figure out what this is. So there are different types of mass wasting. But first, it's defined as any type of downslope movement of earth materials, including soil, rocks, snow, water, etc. So this is basically, mass amounts of earth material flowing downhill. Movements can include sliding, like landslides, falling, like rock falls, flowing, like debris flows, or what it typically is a complex combination of two or more of those things: sliding, falling, flowing, etc. So there's actually 9 different types of mass wasting, and I'll try to just briefly describe each of those. So I'll go through each of these. As I'm going through them, it's all confusing to you. They're all forms of mass wasting. This is all earth material moving downslope. Sometimes it's fast, sometimes it's slow. First is a rotational landslide. So landslide is a specific type of mass wasting. A rotational landslide is when you have a rupture surface that's curved kind of concavely, and the slide kind of curves out before it flows down. So you get this kind of like curved bowl shape to it. That's a rotational landslide. And you can kind of see that shape here. You can kind of see that shape here in this little itty-bitty rotational landslide. But then you also have a translational landslide. Kind of the same stuff, but in this case, it's just moving down a flat planar surface. The material is sliding on a flat planar surface. It's not kind of rotating out. Oftentimes with landslides, it can be induced by water and precipitation, but sometimes it's just the material and gravity just doing its thing. So here's a translational landslide. It might be kind of hard to see, but it's more of a flat planar landslide. Getting into block slides. So this is a translational slide, so a flat planar slide, in which the moving mass consists of a single or maybe just a few very big pieces of earth moving downslope. It's a block slide. In the landslides, you can see it's more a bunch of material, rubble. In a block slide, it's more just bigger pieces kind of sliding off. So you can imagine the big pieces here of this mountain face kind of sliding down this flat surface. To give you some reference, you can see some people here to give you an idea of how big a scale something like that would be. Now you have rock fall, very similar-ish to a block slide, but a rock fall is when kind of big pieces of material, rocks and boulders, kind of fall and catch some air. They're in free fall. At some point they're in the air. They've broken off and they're falling through the air. Hence a rock fall. If they never fell, then they would just be sliding. It would be a block slide. But once they, if they fall off a side and they've got a little free fall, got some air to it, then it's a rock fall. They could eventually bounce and roll, but again, they're still going to get some free fall as they fall off the cliff face. So you can imagine, this is built up over time, you can imagine just a piece just falling off and then hitting, bouncing and rolling and coming to a stop. A topple, kind of similar to a rock fall in that it's usually a big piece of rock falling off a cliff, but in this case, you don't get any air. It doesn't free fall. It just kind of tilts and flops over without it catching any air. So you can kind of see that in this diagram. Imagine this block was here and it just kind of falls over, topples over. So you can see that these rocks just kind of just toppled over, just fell over. They didn't really, free fall, fly through the air. They just kind of fell over. All right, now we're getting into some flows. A debris flow is a combination of typically loose soil, rock, organic matter, trees, branches, that kind of stuff, air mixed in, and definitely water. And this whole slurry of stuff, this whole milkshake of stuff flows downslope. Commonly, these are caused by intense surface water flow due to heavy precipitation or rapid snowmelt. These can be really triggered by flash floods. To kind of connect what we've been learning about. Additionally, if there's a wildfire in the area, wildfires can strip slopes, hills, mountains of vegetation. They can burn all the trees. And those trees do a good job of holding soil and material in place. And if you burn down the trees, then you're burning down that system that holds material in place. So after fires, debris flows are very common because, again, you don't have that material anchoring the soil and dirt in place. Plus, you have all this burnt material, all this rubble all around, and it mixes with water, especially if you get a big storm after a wildfire on a mountain, slopey, hilly area. Sometimes debris flows are called mudslides or mud flows. Definitely more water intensive than some of the previous types of mass wasting. So here's a kind of a muddy mess. You can see big giant boulders, but most of this is water and dirt. So it's a debris flow. We'll spend some more time on that in class. And then you have a debris avalanche. Very similar to a debris flow, except it's typically on a more steeper incline, and the stuff just moves much faster. So kind of the same idea. A lot of typically precipitation, so water soaking into dirt and the ground, causing it to kind of liquefy, causing these kind of mud flows. All right, you can kind of see this, how it kind of just flowed out. You can see how it's kind of full of water. So, yeah, if it wasn't so full of water, that might just be a regular old landslide. But you can tell, the trees here are gone. It might have been for... It probably wasn't a fire. It was probably just logging or just cutting down the trees. If it was a fire, then you'd expect everything else here to be burnt. But still, same deal. If if deforestation occurs or logging occurs, you're removing that system that anchors stuff in place, and you can get stuff like this. But yeah, so if the trees were still there, if there wasn't so much water, it might have just been a translational or rotational landslide. But definitely, based on everything being bare, the amount of water content, how muddy it looks, that's definitely a debris avalanche because it's a very steep slope. Before we go on, let me give you part of the super secret code. It is the number 4. You got it? The number 4. All right, what else we got? Earth flows. So earth flows have a characteristic hourglass shape to them. The slope material up high liquefies and runs out, forming kind of a bowl or depression at the head. Very similar to a debris flow, maybe just a little less water. Again, if you're trying to memorize all these different ones, don't. Just kind of take it all in. And if these are all confusing to you, just remember they're all forms of mass wasting. All right? Don't get tripped up on trying to remember all the details here. So here's a great example of an earth flow. Again, just a little drier than a debris flow. Doesn't really flow as far or as fast. I don't know if you can see up here is where it looks like this mass wasting event started. And then it kind of formed this hourglass shape down here at the bottom. And so that's kind of on the slower slide. And probably the slowest mass wasting style is something called a creep. Creeps are sometimes imperceptibly slow. You can't even see it. It's so slow. But they're slow, steady. They keep slowly creeping downward. You'll know if a creep is occurring by a few things. Curved tree trunks, more on that in a second. Bent fences or retaining walls, tilted poles or fences, or small soil ripples or ridges. So you can kind of see it here, some ripples on the surface, fences that have been kind of altered, tilted poles. And one of the weirdest indications of creep are curved tree trunks, like this. So what this indicates is that this is moving so slowly that, all right, the slope is creeping downward, so these trees tilt. So every time this slope creeps, the trees tilt downward, and then they kind of grow back vertical. They have enough time to grow back vertical. Because trees grow up because they want to get sunlight. That's why they always go straight up. So you can see these curved trunks that really indicate over time, as the thing was growing, it was tilted and it started to curve back up. Tilted, started to curve more back up. Tilted, started to curve more back up. And so that's where you get this curved tree trunk. They look weird, they look ominous, but that's an indication of creep. Very slow moving earth movement, slow moving mass wasting events. So those are the 9. And then I usually throw this one in because it is earth material, it is water, it can be solid material. Avalanches. I don't typically talk about it too much because, we don't have a lot of snow around here. But, we'll throw it in there. It is mass wasting. Is it a bunch of stuff moving downhill? So either heavy snowfall or heavy winds, and even people, skiing, hiking, any number of things, and animals can trigger an avalanche. They usually occur when you have some heavy layer of snow kind of sitting on some older, unstable, weak layer of snow. You have these 2 different slopes, and it's usually, or these 2 different snowfalls, and it's usually that top layer will just kind of slide and slough off. There's a bunch of different types of avalanches. Slab, loose snow, and the motion. They could be through the air, it could be on the ground, it could be a mixture of both. We don't need to go into detail with it, but just know it's snow moving downhill. That's mass wasting. Oftentimes, as this stuff kind of picks up, almost like a pyroclastic flow, it could be kind of buoyed and floating on a layer of air, which is why it can be so very fast oftentimes. However, I don't want you to die. Okay? So if you ever do find yourself in an avalanche, here's 2 quick tips. I mean, you could use this in a landslide as well, or any type of mass wasting event as well. I don't know if it'd work out as well, but you can give it a shot, but definitely for avalanches. If you're caught in an avalanche and you're going downhill, try and get your feet forward and try and dig your feet down into something hard and attempt to backstroke uphill. It's going to keep you up on top of the flow of snow. If the flow comes to a stop and you get buried, what you need to do is put your arms across your face to kind of create an air pocket. You need some space for some trapped air. Because if your arms are down and the snow covers you, then the snow covers you and you're going to suffocate. But if you feel yourself coming to a stop and you feel yourself getting buried, cover your arms over your face. That way you've created just a little air pocket for yourself, and then try to penetrate the surface with an arm if you can. Remember, I don't want you to die. I hope you never get caught in an avalanche, but if you do, remember these words. We'll pause here for just a second. When we come back, we'll talk about the factors that might spark a mass wasting event. I'll see you back here in just a second.